Good evening and welcome to week 11. Today we are doing lecture 1, which focuses on production costs, demand, and profit maximization. The readings are Lipchewski, Wilson, Goddard, chapter 2 to be specific. Specifically in this seminar, we will be looking at production and costs, demand, revenue, elasticity, and profit maximization. First, what we need to do in our discussion of production and costs is distinguish between factors of production that a firm can vary in the short run and factors of production that can be varied only in the long run. In other words, they cannot be varied in the short run. So we assume that there are essentially two inputs, and this is labor and also capital. And we assume that we can change labor in the short run. We can either employ more people or we can dismiss some people. So one of these inputs is changeable in the short run. On the other hand, if we want to change capital, this happens in the long run. Why? Because we need to purchase factories, build offices, purchase machinery, and so on. So therefore, what we assume is that labor is variable in the short run, whereas capital is fixed in the short run, but variable in the long run. In other words, both resources or both inputs are variable in the long run. In the short run, only labor is variable. This leads us to a so-called long-run production function, which proposes that output is a function of these two inputs, specifically labor and also capital in the long run. Why? Changing either of these will impact production. However, we can also set out a short-run production function, and the short run, we assume that output is dependent only on labor, and that is because capital is fixed in the short run. Next, we delve into some of the relationships between output and also the level of inputs. Specifically in the short run, if we speak about inputs, these are labor. And what we note is that after a certain point, as we increase the number of employees, what happens is that the marginal product of labor begins to diminish. In other words, we see the law of diminishing returns to labor, or a diminishing marginal product of labor, occur. So if we start with one employee, so one employee produces 7 units of output. As we increase our level of employment to 2 employees, the next employee contributes 19 units. Now we have a total of 26 units. So 19 is the marginal product of labor. But as we go along, what happens is that the contribution of each additional worker decreases until it is potentially 0. So this is what we see happening here in this situation. Why is that the case? Because we assume we have a fixed amount of capital. So while workers can initially utilize the capital that they have, what creeps in after a while is that there's simply too many workers and too little capital. And that is when we start seeing a diminishing marginal product of labor. So a diminishing marginal product of labor, or specifically or more generally diminishing returns, set in because the quantity of capital is fixed. How do we calculate the marginal product of labor? It is the change in quantity for a given change in labor. So here, as you can see, the increase in output from the second to the third worker is 28. So this is the marginal product of labor. The third worker contributes 28 units to total output. Next, we define another measure, the so-called average product of labor. So this is the ratio of total output to the quantity of labor employed. So for example, in order to find the average product of labor, what we do is we divide a specific level of total output, let's say 54 units, by 3, and the result of that is that the average product of labor is 18 in this instance. So all the average product of labor is the level of output divided by the amount of labor that we are currently employing. What you will also see is that as output increases and the amount of total output increases, and the amount of labor increases, what happens is that the average product of labor begins to fall. And this is related to the decline in the marginal product of labor beyond a certain point, as you see here. And we will discuss that very shortly. Now let's look at the short-run relationships between total, marginal, and average product of labor. So let us begin with the marginal product of labor and the average product of labor. What we see is that as long as the marginal product of labor curve is above the average product of labor, what happens is that the average product of labor curve is upward sloping. Think about it this case. Let's say you have written a series of tests and you have 50%. That is your average. What happens if the next test you get 60%? That is a marginal test in this instance. Well, what we'll do is it will pull up your average. On the other hand, if you get 40%, that will pull down your average. That is 40% in the next test. It is exactly the same with the marginal product of labor and average product of labor curves. As long as the marginal product of labor is above the average product of labor, what happens is the average product of labor will be increasing. As soon as the marginal product of labor is below the average product of labor, what we see is a downward sloping average product of labor curve. To add to that, what will keep on happening is that output will keep on increasing, but by less, right up until the point that the marginal product of labor becomes negative. So as long as an additional worker produces a positive amount of output, regardless of how small it is, total output will rise. But as soon as it drops below zero, in other words, it becomes negative, what happens is that output begins to decline. Next, what we do is we define the variable costs and fixed costs and total costs. So let's say that each worker receives a salary of £200 per week. That is our variable cost. Why? Because as we hire more workers to produce more output, the costs associated with the amount of employees, these change. So hence these are variable costs. And these variable costs are associated with a short-term input. In other words, labor. There is a second type of cost, and that is a fixed cost. So for example, you are entering a factory. Now, a fixed cost is fixed because it doesn't matter whether you are producing in that factory or whether you are not producing in that factory at all. The cost remains the same. So in column 5, what we see is the variable cost. The cost rises as we employ more employees. At the same time, what we also see is an increase in output that is associated with employing more employees because they are required to produce output. On the other hand, the fixed cost remains the same, whereas we produce only 7 units or we produce 242 units in total. Now, the total cost is the sum of the fixed cost and the variable cost for a given level of output. So here we are employing at this point only a single worker, which we are paying, or whom we are paying £200, and the fixed cost is 1,000. So the total cost per week is 1,200. And this cost increases as we produce more output and we hire more workers. Next, what we can do is we can define specific costs in terms of averages, in terms of marginal costs. And much like the average curve product of labor and the marginal product of labor, these curves or these costs are also linked in a way. So let us begin with something called the short-run marginal cost. Note, we call it the short-run marginal cost because this is a cost that changes with the increase of output, which is related to a change in the short-term resource, because we need to hire more employees in order to produce more output. The formula for that is the change in the total cost divided by a change in quantity. So for example, when we are producing 7 units of output, what is the change in the total cost? Well, the change in the total cost is 200 because we need to hire 1 employee. So hence, we divide 200 by the units of output, and our short-run marginal cost then is 28.6. Now let's say that we are now producing a quantity of 26, a total quantity of 26. In order to produce that quantity, we need to hire 2 workers, and hence, sorry, we need to have a total of 2 workers employed. That is an increase in the labor force by 1. So our costs increase by 200, but our output, our marginal product of labor is 19. That is how we land up at a total of 26. So again, it is 200 divided by the marginal product of labor. In other words, the change in output, which is 19, and hence we are at 10.5. Now note, as long as the marginal product of labor is rising, then the short-run marginal cost will fall. Why? Because that means that each additional unit or each additional worker employed or unit of labor produces more than the previous one. That's what happens when the marginal product of labor rises. Hence, as each employee costs 200, yet the amount of output produced increases, the result is that we see a falling short-run marginal cost as a result of that. But as you know, that the law of diminishing returns will set in. That is when output per worker will begin falling as we employ additional workers, yet the cost will remain the same. And the result of that is that we have a rising short-run marginal cost. Next, what we can do is we can define an additional 2 types of costs, and that is the average variable cost and also the average fixed cost. How do we calculate the average variable cost? It is the variable cost divided by the quantity. So let's say we have a variable cost of 1,000, and that corresponds to 5 workers. Remember, the variable cost changes as we produce more output by employing more employees. So we divide the variable cost by the total level of output, which is 125, and what we land up with an average variable cost of 8 per unit of output. What we also have is we have the average fixed cost, and the average fixed cost is simply the fixed cost, which is 1,000 throughout. Remember, the fixed cost doesn't change regardless of how much we produce, divided by the level of output. So again, we would divide the 1,000 here by 125, and we would have a figure of 8. So that is the average fixed cost. But note, the average fixed cost keeps on declining as we produce more output. Why is that? Because it is fixed. It stays the same regardless of how much we produce. Finally, what we have is we have the firm's short-run average cost, and this is the total cost divided by the level of output. So for example, here we add the variable cost, which is 2,000, to the fixed cost, and that is equal to 3,000. And then what we do is we divide it by the total units of output, which is 250, and we find that the short-run average cost is 12. Let's put all of these curves together. We begin with the one that is easiest to understand, and that is the average fixed cost. So as output increases, what happens is we see a decline in average fixed cost. So first, it's 1,000 divided by 10 units of output, followed by 1,000 divided by 100 units of output, and hence, as you can see, the average cost per unit of output decreases. Next, we turn to the discussion of production costs in the long run and production in the long run. So as you recall, in the short run, we could change one of the inputs, and that would be labor. Now, in the long run, we can change both inputs, including capital. So hence, not only can we employ more workers, but we can also now purchase more plant and machinery to use in the production process. And what this allows us to do is to take advantage of returns to scale. And there are 3 types of returns to scale, specifically increasing returns to scale, constant returns to scale, and decreasing returns to scale. What do returns to scale mean? Well, let's start with our first variant, and that is increasing returns to scale. What this is that output increases more than proportionally in response to inputs. So for example, let's say we increase our labor and capital by 1%, output will increase by 2%. So input will be increased by more than our increase in inputs. What we also then have is decreasing returns to scale. And what this means is that our output will increase, but by less than proportionally to the increase in inputs. So for example, inputs will increase by 1%, but output will increase by 0.5%. So therefore, output increases at a slower rate than our increase in factor inputs. And then we have constant return to scales, which we see here, and this occurs when output increases proportionally with an increase in inputs. So for example, you increase inputs by 1%, output will also then increase by 1%. And the idea is that what we want to do is we want to take advantage of economies of scale, that as we produce more, what happens is that our production costs begin falling. At least some of them begin falling. Therefore, let's talk about economies of scale. So what exactly are they? Well, we can have two types of economies of scale. So first of all, there are real economies of scale, and these are economies of scale that arise with savings in average costs due to changes in the quantities of physical outputs. So as you produce more, costs begin to fall. That is essentially what it is saying. Then we have pecuniary economies of scale, and these are associated with savings in average costs due to changes in the price paid by firms for its inputs or factors of production. So their factors of production become cheaper. So for example, as a firm increases its level of production, what happens is that certain employees start specializing. So as a firm grows, instead of a few employees doing everything, employees start specializing. So as they specialize, they become more efficient, their skills increase, and the result is that they become more productive. So hence, less time is wasted through workers having to switch from one task to another. So as you can see, there we would have economies of scale arising as a result of this specialization. So hence, average costs are then reduced. Another example is you start having specialization management. So managers of a small firm oversee and manage absolutely everything. They perform many tasks, but they might lack specific necessary expertise to perform some or all functions effectively. So what happens as a firm grows? Why is it growing? Because it's producing more output, it's selling more. That is the source of its growth. What is it that happens? It starts employing specialist managers that perform each function separately. So hence, again in efficiency. Here are some further examples of real economies of scale. So first of all, what may happen is you have large-scale production, and large-scale production is simply more effective than small-scale production. So what happens is that you purchase larger machines to produce because you are producing more, and such a machine may produce more output than two small machines combined and is also now cheaper. So you are essentially producing more at a lower cost per unit. What we also then have is this idea of indivisibilities. So let's say you have a receptionist and you pay that receptionist a certain salary. And let's say initially you are producing 5,000 units. Well, whatever that salary divided by 5,000 units, that is the average cost per unit of that receptionist. But what happens if you increase the number of units you are producing? Well, the average cost per unit of that receptionist then falls. Now, why do we talk about indivisibility? Well, the reason why is because that reception is not divisible. Regardless of how many units are being produced, there's still one reception that provides reception services to regardless of how large production is. What we also have is learning economies, and these are an important source of cost savings. So what happens over time is workers and managers become more skilled as they repeat the same task. And as they repeat the same task, the length of the production process also comes into play. Why? Because the longer it is, the more they get to repeat it. So hence, they become more specialized and more knowledgeable. Because they are more knowledgeable and more specialized, what is it that happens? So let's just say they are more skilled. Well, they are more efficient. That results in cost savings. So again, the idea is that the more output you produce, the lower the costs per unit of output. Let's talk about pecuniary economies of scale. So why do these arise? These arise in large firms as large firms find it easier than small firms to raise finance. So, for example, a large firm may be able to offer its lenders stronger securities than a small firm. Why? Because a large firm is likely to have a lot of assets, and hence it can use those assets for collateral, specifically a lot more than a small firm. So hence it is lower risk. Also, a large firm may access sources of finance unavailable to a small firm. So a large firm may, for example, be listed publicly, so it may raise finance on the stock market. Relatingly to the first point, lenders may believe that a large firm poses a lower risk. Why? Because it may operate in multiple markets. So let's say it's operating in the United Kingdom and in Russia. Let's say that in Russia its products are no longer purchased. Well, it has a level of diversification because it will still make money in the United Kingdom. So there are still cash flows, even though it's not doing well in a given market. Similarly, it might have multiple plants are used in the production process, and the result of that is that if one of those plants goes down and stops producing output, there is another plant where it continues to produce output. Also, large firms can buy and sell in bulk, and hence they benefit from purchasing and marketing economies. So, for example, a large firm has the market power to negotiate favorable rates of inputs if it is a major buyer for a given input. Let's say mining equipment, unlike a small firm, which doesn't buy a lot of mining equipment and hence doesn't have as much negotiating power. Then what we have is large firms being able to access large-scale forms of advertising, such as television advertising, which could be beyond the means of a smaller firm. Again, it is then able to sell more and reach economies of scale. Also, a large firm that supplies a national market as opposed to a region or a city can realize transport economies. Because it operates nationally, what it can start doing is it can start producing in specific regions and distributing on those regions. Alternatively, what we can also observe are diseconomies of scale. So these arise when long-run average costs tend to increase as output increases. So this is the opposite of economies of scale. Now, why would it cost more? Why would the average cost rise beyond a certain point? Well, think about it this way. So you have a management team, but after a while, the organization becomes so large that the management team is too small or simply can't oversee the entire company and firm. So what happens is there's simply difficulties that are encountered in managing large organizations, and this is then associated with rising costs and we produce more output. So the opposite of economies of scale. So what are the sources of managerial diseconomies? First of all, for example, strained communications between different tiers of management or between different parts of the organization, because the organization is simply so big. Long chains of command and complex organizational structures. So it's no longer easy to get things done, or it is no longer quick to get things done. So hence, for example, a firm can't readily respond to changes in market conditions. Also, what we may see is low morale amongst the workforce. where personnel begins to feel as a number is no longer interested in the performance of the organization, because there's no identification with the organization. There's no sense of belonging. So hence, the efficiency and the output of individual employees begins to fall. Also, there are potentially poor industrial relations due to the complexity of relationships between the workforce and management or different groups of workers. So, for example, trade unions start arising. There are disagreements between management and workers, and there are also strikes. There are also interdepartmental rivalries, and of course, this does not contribute to lowering costs. We can extend this concept of economies of scale to a related concept and the so-called economies of scope. So these are cost savings that arise when a firm produces two or more outputs using the same set of resources. So for example, you may have the same microchip that is used in the manufacturing of several different consumer electronics. So you can use a microchip that you can put into cell phones, and you can use the same microchip to also be used in tablets. So what happens in this instance, that the diversified use of these resources causes average cost to fall if the total cost of producing several goods or services together is less than the sum of the costs of producing them separately. Which would be indeed the case. Think about it this way. Let's say you wanted to produce tablets and cell phones. You can choose to produce them in different locations using different technology. Of course, this would be more expensive. Alternatively, you can produce them in one location and use exactly the same resources, and also use the same staff to produce both goods, or the same workers to produce both goods. Although cell phones and tablets are different, you can see that a tablet is not a massive jump from a cell phone. So hence, that offers a realistic scenario for economies of scope. Then finally, we have the minimum efficient scale, and this is defined as the output level beyond which the firm can make no further savings on the long run average costs through further expansion. Next, we turn to demand, revenue, elasticity, and the issue of profit maximization. But before we do so, what we need to do is we need to discuss a couple of components. Well, first of all, what is market demand? Well, you are quite familiar with demand on an individual level. It is the relationship between the quantity demanded of a good and a given price. So for example, what we see in column 1 is that when the price is 1.6 pounds per unit of a hypothetical good, 3 units are purchased. The corresponding total revenue is 4.8, and then the average revenue is simply the total revenue divided by the quantity demanded. So the average revenue is then 1.6, essentially the price. What is the marginal revenue? The marginal revenue is the change in total revenue with the sale of additional units. So when we sell the third unit, what happens is that our total revenue is 4.8. When we have sold 2 units in total, our total revenue is 3.6. So the change between 3 units in total being sold and 2 units in total being sold is 1.2, and that is the marginal revenue. Then what we see is the price elasticity of demand. Recall what the price elasticity of demand is. That is the responsiveness in relation to the price. And as a good takes up less of your income, the less responsive you are. So for example, what you see is that the price elasticity of demand declines. Now let's take a step back and discuss total revenues again. So let's say we are dealing with a monopolist. So the total revenue, as discussed, is equal to the price multiplied by the quantity. So this is a bit of a repetition. Again, here what we have is we have the formulas where the total revenue, where the average revenue is the total revenue divided by the quantity, where the total revenue itself is price times the quantity. So hence average revenue can then be equated with the price. So that is what comes out of it. So now this brings us to the question. Let's say we are dealing with a hypothetical situation of a monopoly. What is the effect of a reduction in price on a monopolist's total revenue? Well, the answer is that it depends. So a monopolist could either experience an increase or no change or a decrease in total market revenue, depending on the point on the market demand function from which the price reduction is introduced. Note, this ties into the price elasticity of demand. So two things can happen. You can have a so-called quantity effect. The quantity effect will work when more output is sold. In other words, you have to have an price elastic demand. In other words, you drop the price, the result is that more output is sold. And the sales and output are greater than the decline in receipts due to the lower prices. And hence, because you are selling more output, what this does is it offsets any loss associated with lower prices. So hence, in this instance, total revenue will increase. But now, alternatively, let's say that prices decline or the monopolist decides to lower the price. What can happen here? Well, it can be that consumers are not responsive to a drop in the price. The idea is that the price would decrease, and the result would be that consumers would buy more of a specific product. But what if price elasticity of demand is inelastic? In other words, they don't respond to changes in the prices. So hence what might happen is that a monopolist might decrease prices, but more output is not sold. What is the result of that? Then revenues begin to fall. So we have two effects that work in opposite direction. We have the quantity effect. The idea is that consumers respond to changes in the price and they start purchasing more of a product, and the quantity effect dominates. So the increase in the quantity sold dominates the decrease in prices, and hence revenues increase. Alternatively, you may also have a price effect that works together with a quantity effect. So remember, the idea is that the quantity effect should dominate the price effect. But alternatively, what can happen is that you have the decline in price, so the price effect begins to dominate, but there's no change to quantity, so there's no real quantity effect. And as a result of that, revenues tend to decrease. So in summary, if the quantity effect dominates the price effect, total revenue increases as prices fall. So this is where we are at. We are selling a much greater quantity because consumers are quite reactive to changes in the price level. So hence quantity increases, and the quantity effect dominates the decrease in the price. Then, if the quantity effect just balances the price effect, total revenue remains unchanged as the price falls. So in other words, yes, you have a decrease in price and a little bit more is sold, but the decrease in price is offset, or the high quantity sold, the quantity effect is offset by the so-called price effect. So high quantity is sold, but prices have decreased, and hence there's no real effect on total revenue. Then what we have is the quantity effect being dominated by the price effect. In other words, in this instance, you drop the price, but the quantity doesn't increase by much to offset the decline in prices. And hence, what we see is total revenue decreasing. This is when we go back to this discussion of the price elasticity of demand. So what is the price elasticity of demand? Specifically, it is the proportional change in the quantity demanded in respect to the proportionate change in the price. And what we are asking ourselves is how does the quantity demanded respond to a given change in the price level? Specifically, how does the quantity demanded respond for a 1% change in the price level? So we calculate a percentage change, and here we have the formula. Okay, so this essentially gives us the percentage change. So it's the change in the quantity So new minus old divided by the old quantity, divided by the change in the price, percentage change in the price. Okay, so all of this links to the change, percentage change in the quantity for a given percentage change in the price. And that is how we calculate the price elasticity of demand. Now let's delve into this discussion of the price elasticities of demand. So if we calculate that the price elasticity of demand is greater than 1, we don't state it in percentage, we state it as a unit. What this tells us is that total revenue increases as the price falls. Why? Because the change or the increase in the quantity demanded is greater than the decrease in the price. In other words, the increase in the quantity demanded offsets, or the revenues associated with the increase in the quantity demanded offset the decrease in the price. What happens if the price elasticity of demand is 1? Okay, in this instance, the total revenue remains unchanged. So we decrease price by 1%, while the revenue associated with an increase of quantity sold increases by 1%. So there is an offset. The quantity, the increase in the quantity and the revenue associated with that is offset by the decrease in the price. Then what we have is a price elasticity of demand is less than 1. In other words, the quantity demanded is not reactive or does not react to changes in the price. So we might decrease the price, but this will not be offset in a greater quantity sold and hence an addition to revenue that will offset the decrease in the price. And in this instance, we will see the total revenue decreasing. One final point to add. So why does the price elasticity of demand differ as prices change? So it differs along the demand curve. Well, the reason why is that when a good represents a small proportion of your income, we are not as impacted, or in other words, we don't respond to changes in the price level than when it corresponds to a large proportion of your income. And then you are very sensitive to changes in the price level. Okay, so the price elasticity of demand can vary, and it can be elastic and inelastic depending on the proportion of income that you spend on a given good, which is of course related to the price. So now this brings us to a summary of a monopolist's short-run production function. What we see is that the total cost is the sum of the production of the firm's variable cost and its fixed cost. And what we also see is then column 9 that the monopolist's profit is equal to the total revenue less the total cost. And that gives us the profit. Now, the point at which a monopolist maximizes revenue is the point where the marginal revenue is equal to the short-run marginal cost. So just simply the marginal cost. Remember, this is a very important condition. Let us therefore break this a little bit further. This idea of marginal revenue equal marginal cost, with the quantity corresponding to that being the quantity that maximizes total profits or monopolist profits. So let's say we start from a quantity of 0. We are selling nothing at all. And then we start selling 1 unit, and we sell that unit at a price of £2. So what is the increase in the associated cost? Well, we say that marginal revenue is 2, and then the short-run marginal cost is 0.5. Right, that comes from column 7 specifically. So now profit increases with the sale of 1 unit from -1, which is the fixed cost, which represents purely the fixed cost, to 0.5. So we sell 1 unit at a price of 2. Our total cost, which includes a fixed cost and a variable cost, is 1.5, so hence our profit is 0.5 at this point in time. Remember, the short-run marginal cost corresponds to the changes in total costs associated with increasing output, and that in turn is driven by changes in variable costs that arise as a result of the need to employ more flexible resources, or resources that can be changed in the short run. Now, let's say we increase our sales from a quantity of 1 to a quantity to 2, or to 2. The increase in the profit is then 1.4. Note this jump here, which comes from these figures, where profit is the total revenue corresponding to 2 units being sold less the total costs. So that is how where we see the new level of profit, which is 1.9. Now, as we increase our output and sell our output from 2 units to 3 units, we see an increase in profit from 1.9 to 2.6. Again, it is our total revenue less our total costs, and hence we have our profits. Then what we do is we produce an additional unit. We go from producing 3 units to now producing 4 units. Of course, this is associated with a higher total revenue, but we also now assume a higher short-run marginal cost of 0.8. How do we derive that? Well, we are given these total costs, and as you can see, the difference between these two figures is 0.8. So what is our change in revenue, our marginal revenue? It is 0.8. So although our revenue increases by 0.8, so do our costs with selling an additional unit. In other words, selling the 4th unit. What is the result? Well, if marginal revenue is 0.8 and the marginal cost is 0.8, in other words, the revenue obtained from selling the 4th unit is 0.8, and the cost associated with producing and selling the next unit is 0.8, the 4th unit. Therefore, the marginal revenue is offset completely by the marginal cost. So what is the result? Well, profit no longer increases. And that here is how we arrive at this condition as to when the marginal revenue is equal to the short-run marginal cost, the monopolist can earn a maximum profit. So let's just do a final example then. So let's say we are now selling 4 units and we are maximizing our profits. In other words, the marginal cost associated with selling to the 4th unit is equal to a marginal revenue from selling that unit, and hence there's no increase in profits. But let's say now we want to sell a 5th unit. So we sell a 5th unit, and that is associated with an increase in costs, in total costs of 1.1. So that is our marginal cost associated with that sale. However, what is it that we see? What is our increase in total revenue? It is 0.4. It's 6 less 5.6. So 6 is what we have with selling 5 units, and 5.6 is what we have with selling 4 units. So therefore, our marginal cost is 1.1, but our marginal revenue is 0.4. So what does that mean? Well, that means that the cost exceeds the revenue, and hence our total profits now begin decreasing. And that is why you see why that condition of marginal revenue is equal to marginal cost is a profit maximizing condition from a monopolist perspective. Thank you, and that is it for now.